Hello everyone, my name is Narvin Sachania. I am a team leader of Word Squad, and today I have a presentation AI personal knowledge twin. So this is my selected problem statement, and I will institute all our point, including our presentation. So that first of all, I will explain our project overview. The personal AI knowledge twin is a persist AI memory system designed to continuously capture, organize, and retrieve user knowledge from multiple information sources. The system ingests, understands, and semi-structured data, such as a PDF notes, meetings, transcript, and conversation, converting them into machine understandable representation. So then it's employ vector embedding to store knowledge, cinematically enabling the context aware to similarity based retrieval rather than keyboard search. A knowledge graph layers constructor and represents relationship between the concept, topic, and documents, supported deeper and contextual reasoning. The architecture follows our multiple layer pipelines consisting of the data injection, processing, embedding, journal memory storage, and intelligent retrieval. And then the system support continuously learning, avoid incrementable update to memory without reprocessing the entire knowledge base. Conceptual recall mechanism enable the AI retrieval and information based current task. This is all or part of the overview of project. Then what our tag use in my project. So first of all, I will use LLM models for the understanding, summarizing, and reasoning all or part of their natural language comparison capability. Then embedding model convert to text document and convertible into the high dimensional vector. Then I will use vector database. For an example, FAISS, Pinecones, then Weaviate, etc. Selected this vector database used for the regarding selector efficient similarity, search scalable storage, and systematic embedding with low level retrievability. Then I will use a knowledge graph database. In this use, I will mostly use any Neo4j. So this is a relationship between the concept enabling structure reasoning and the visual knowledge expert. Then mostly use backend framework first fast framework, otherwise a Flask for the high performance APIs handling data injection and processing pipeline and AI inference request. Then I will use mostly Next.js for the SEO friendly front end framework, better visualization user interface, and for the speak to text engine use Whisper or equivalent for the user speech audio convert to the text integration. Then I will use for the document processing tools PDF parser OSCR engine to text convert into the PDF scan document image support driver data source. Then database for the metadata storage use the PostgreSQL for the structured data. And security and privacy layer, I will use encrypt and access control for better user safety regarding and user level authentication and optional device processing. Then my what approach I will use in my project. So for mostly I will use a modular and incredible development approach to allowing the independent and testing system. The initial phase focus requirement analysis and data source identification, definition type of the documents, conversation and meeting to be processed. The data injection pipeline was implemented. The first handle the document upload, text extraction and meeting the transcription. Then text processing technique I will use chunking and normalization and metadata tagging were applied to prepare data from cinematic embedding. And embedding generation and vector storage were implemented. The next enables cinematic memory and similarity based retrieval. A retrieval mechanism was developed to fetch the retrieval knowledge from the vector database on user query and contextual signals. Then LLM based reasoning layer was integrated for to perform summarization, contextual response, and journal and inter-result recalls. Then I knowledge the knowledge graph component was added the establish relationship between the concept and supported structure navigation. The follower part to connect to the backend API were designed to using stateless service architecture to use scalability and maintainability. So this is our diagram. In this user interface using the web or mobile dashboard, send our chat query and knowledge graph in view memory management, so all our chat parts. Then go to the backend API layer and request handling to going to the request in backend servers, then authenticated user and architecture logic. Then all our fetching the other text, voice, PDF documents are uploaded in data integration layer and chunking and node conversation. Getting layer to text extraction OCR engine using and cinematic vectorization to database using the Pinecone metadata source using PostgreSQL, and then we will go to the knowledge graph database. These are the used for the embedding modeling and cinematic visualization and vectorization, and speak to the text engine convert to the PostgreSQL user speak data, otherwise voice data using Whisper, and then go to the intelligent layer LLM model. LLM model are continuously token wise generated our answer and show in the dashboard retrieval and summarization, predictable recall and response generation using natural level reply to productivity suggestion. Then now about my architecture user interface layer, this is a provided in interaction in all our already. I will explain all our part. First of all, user level interface, then API in backend layer using Next.js and Node.js, otherwise Next.js with PostgreSQL database injection layer using the PDF source OCR engine, processing the pipeline using OCR engine for chunking and CACDs, then embedding layer for the process the numerical vector representation to this vector, capturing the cinematic meaning, enabling and separate base. Then metadata source using the timestamp document source tag, all our part as filtering and ranking the contextual grounding the retrieval and graph continuously real-time database incredible and decredible relation between concept topic and document, enable the structure reasoning concept linking, then speech to text engine or to work based on other user speak, then engine understand the voice and convert into text layer, and LLM using the LLM model, large language model, to perform the reasoning of a retrieval model to combine cinematic search results, graph and relationship and concept journal, meaningful insight and answer response journal. Final layer format the output into the natural language response, summarize graph inside our productivity suggestion, the response in the delivered back in the user interface. Thank you so much our team. So, and I will all over part of selected in this cover, and I will also share my GitHub repo and hosted project link with my, yeah, YouTube video.